Hello, this is Scott Dahman of PowerWorld Corporation. In this session, we will discuss PowerWorld Simulator's limit monitoring settings. With limit monitoring settings, you can tell PowerWorld Simulator what is considered an overload or a voltage violation and what is considered a normal operating condition. Most advanced tools in PowerWorld Simulator use the limit monitoring settings. In the contingency analysis, what is considered an overload during a contingency is determined by the limits that are set in the limit monitoring settings. Similarly, with the advanced transfer capability tool, when you're transferring power between a buyer and a seller in the system, the ATC tool will tell you how much power can be transferred before a limit is reached. The optimal power flow enforces transmission limits and interface limits when it seeks the least cost dispatch, as does the security constrained optimal power flow, which incorporates contingency analysis and the optimal power flow. The PV and QV curve tool can be set to ramp a transfer out until voltages become inadequate. The limits for power system elements that you can specify in the limit monitoring settings include MVA or amp limits for transmission lines and transformers, megawatt limits for interfaces, and high and low voltage limits for buses. If you open a new power flow case and have not adjusted the limit monitoring settings, then by default all elements in the system will be monitored. Then you can use the limit monitoring settings to exclude certain elements or to specify which elements should be enforced in the case of the optimal power flow or the security constrained optimal power flow. And then you can also specify what those limits are. And again, just about every advanced tool in PowerWorld Simulator makes use of the limit monitoring settings. In PowerWorld Simulator, click the application icon and open the Midwest.RAW sample case. You may have to select the files of type at the bottom to display the PTI RAW files. Once the case is read in, go to the Tools ribbon and then Solve the Power Flow. And then open the limit monitoring settings from the Tools ribbon also. The Limit Monitoring Settings tool shows some information about some violations or overloads that occur in this case. I have 24 low voltage buses, 19 high voltage buses, and 46 lines or transformers that are overloaded. The bottom section of the display contains tabs to view different power system objects, such as buses, lines, interfaces, and so on. I can choose to view all of the elements in the case in these displays down here, or I can choose to view only those elements that are being monitored. In this case, the set of monitored elements and the set of all elements are the same, because I have not yet specified which elements to exclude from monitoring. If I choose the third option, the violating elements, then the displays down here will show only the elements that are overloaded or violating their voltages. In this case, I can look at buses, and it is sorted in ascending order on the per unit voltage. So these are buses that are either below the low voltage limit or above the high voltage limit. And I can change the sort order too to see the high voltage buses here. If I go to the Transmission Line tab, I can see here the lines that are overloaded, and there are 46 of them. This column right here shows the percent of the limit that's applied that the line is currently operating at, and all of these are at least 100% or greater. The upper right section of the dialog has information about limit groups and then also information about what is considered an overload for each type of object: lines and transformers, interfaces, and buses. Initially, there is only one limit group called default, and every power system object that has a limit associated with it belongs to the default group. I can choose to disable the default group and not monitor it. If I do, then I'm not monitoring any elements in my power system and I have no overloads or no violations. For the lines and transformers and for this default limit group, I can specify what is considered an overload. Initially, 100% of the line's rating is considered an overload. If I want to, I could change that value to say 95% and then hit the tab key to change focus to the next cell, and I can see that now I have 119 elements that are overloading, and every line that is loaded at least 95% of its limit is considered overloaded. I'll change that back to 100%. The next couple of boxes allow you to specify a normal rating set and a contingency rating set. These refer to the rating values that are stored with each line and transformer. Each line and transformer and each interface may have up to 8 ratings, as designated by rating sets A through H. Often, power systems will be modeled such that under contingencies, higher ratings are allowed to be used. So you might have a situation in which you specify a B rating set for contingencies and an A rating set for normal, and the B ratings might be at least equal to or greater than the A ratings. The contingency ratings are then used by simulator during contingency analysis and also the other tools that might invoke contingency analysis, like the ATC tool or the security constrained OPF. If I go back to my Model Explorer and then look at the display for branches input, I can see all the transmission lines in the system, and I can also see the rating sets that are applied for the A ratings, the B ratings, and the C ratings. A value of 0 basically tells simulator to not monitor that line during conditions for which that rating set would apply. If you want to view the other rating sets, you can bring the fields on using the display column options or the fields part of the Model Explorer. They are also shown on the dialog box for the line and transformers and for interfaces as well. Back to my limit monitoring settings. For lines and transformers, you also have the option of treating line limits as equivalent amps. The limits that are specified in the rating sets with the line and transformer records are limits that are specified in MVA. If you check this box right here, what simulator will do internally is convert the MVA limit to an amp limit, assuming that both terminal buses of the line are operating at 1 per unit voltage. Thus, if the line is actually operating at higher than 1 per unit voltage, then for the same amp limit, the line is able to transport more MVA. Conversely, if the line is operating below 1 per unit voltage, then the same amp limit will only allow it to produce or to carry less MVA. Transformers, though, are always monitored with MVA limits. If I look at my list of lines below, I can see this field right here tells me whether or not an MVA or an amp limit is being applied. These are all transformers, which is why the MVA limit is being applied. But if I scroll down, I can see a few records that show amps. Back to the limit group section, if I touch the Interfaces tab, I have basically the same set of options as I do for lines. I can set a percentage for what's considered an overload, and I can choose a normal rating set and a contingency rating set. But because interfaces are always monitored at megawatts, there's no box for changing to amp limits. And finally, the Buses tab allows you to specify generically for all buses what's considered low voltage and what's considered high voltage. And you can have different values for normal conditions or for contingency conditions. In addition, for both normal and contingency conditions, you can also specify a rating set. Buses can have up to 4 different ratings for low voltage and for high voltage. If the rating set fields for the bus are not populated, then that bus would use the ratings that are specified over here. But if you wanted to have a different low voltage limit and high voltage limit for every bus in the system, you could go to the bus records in the Model Explorer and then bring up the ratings and enter a different rating for each bus. As with transmission lines, the rating sets are fields which can be added to the display. They are here under bus-specific limits, so you can have a high and a low volt for each of the 4 rating groups if you wish. There's also a checkbox up in this section which does not belong to the default limit group or any limit group, but applies globally to all limit groups. It says do not monitor radial lines and buses. And if I check it, it will ignore any voltage violations or transmission overloads on lines that are radial. For a lot of large-scale cases, this is a good option to use because in many cases, radial overloads are a result of bad data. For example, a generator might be connected to a step-up transformer that is not rated for the full output of the generator. While it's possible that that could reflect reality, usually it's just reflective of bad information or bad data in the case. Similarly, a load could be connected to a bus with a step-down transformer that's not rated to support the load. I can see that when I check the box, the number of overloads, both with voltages and with lines and transformers, goes down considerably. From the case information displays that are shown on these tabs in the bottom section, I can also choose to monitor or not monitor different elements individually. So if I go back up to the top, I'm going to choose to show all elements in the case. Then in this bottom section, for individual objects, I can choose to monitor or not monitor them by toggling the monitor flag to no or to yes. And I can do the same for buses or for interfaces. You'll notice for buses and for lines, some of these are grayed out. And the reason they're grayed out is because they're not monitored because they are radial. Or in the case of buses, they might be grayed out because they're disconnected. In any case, I can right-click on a grayed field and bring up the local menu and then choose the option, why is this field or line disabled? In this case, the bus is not in service. I could also choose to exclude elements from monitoring based on their area or zone. If I click on the Area Reporting tab, I can see all of the areas in the case, and I can choose for each area to report limits or not report limits. For example, if I were only interested in Area 8, which is Synergy, I could right-click in here and then bring up the local menu and toggle everything to no. and then follow up by clicking on Reporting Limits Only for Synergy. For each area, I can also specify a minimum nominal kV level and a maximum nominal kV level for monitoring. Then only buses, lines, and interfaces that are within the kV range that you specify will be monitored. So for example, I could choose to monitor only lines that are 100 kV and above by entering a 100 in the minimum. Some notes at the top of the Area and Zone Reporting tabs show that areas and zones are not assigned to the limit groups. But power system elements, such as buses, lines, and interfaces, are only monitored if every one of these conditions is true. The individual element has to have its monitor field set to yes. The limit group that it belongs to has to be enabled. In other words, this box has to be cleared. And the area that it belongs to has to be set for reporting, and the element must meet the minimum and maximum kV limits for reporting. I can create a new limit group in addition to the default one by clicking on the tab that says Modify/Create Limit Groups. I can see that I have one limit group called the default, and basically all of the information that is shown up here is also shown in this case information display. So I can see that the group is enabled because its disabled flag field is toggled to no, and that we're monitoring branches at 100% of their limits. We're using the A rating set under normal conditions and the B rating set under contingent conditions, and so forth. If I want to create a new limit group, I can right-click in here and then tell it to insert a new limit group. I can edit the name if I wish. And let's click on that cell and give it a name. Let's call it 500 kV. And I could use multiple limit groups because different elements in my power system then might have different values which are considered overloads. For example, on my 500 kV grid, maybe I want to have different limits for what's considered a low voltage or a high voltage. So I could type in a different value here. So maybe I could put in 0.95 for the low limit and leave the high limit at 1.1. Now I've created the limit group, and the next thing I need to do is then assign elements to it. So I could go back to my buses tab, for example, and then assign different buses to the 500 kV group. Now the name that I gave it, 500 kV, is just that. It's the name that I've given it. If I want to assign all the objects in my case to the 500 kV limit group that are 500 kV and above, for example, I could do that with an advanced filter. So I can open the advanced filter dialog here. And then create a filter that just looks at buses that are 500 kV nominal voltage and above. The details of creating advanced filters is covered in greater detail in a different training topic. But certainly right here, I could toggle all of the columns in the limit group to the 500 kV limit group now. And I've done that just for the buses that are on the display, which are the ones that meet my filter. Also, once I've created a new limit group, I can look at it up here as well. So not only do I have the default in the drop-down, but I have the new 500 kV limit group as well. The slides summarize the things that we've just covered. For example, different lines, interfaces, and voltage limits can be assigned to each limit group, and each device within the limit group will adhere to its own limit group settings. Remember that a power system element, such as a bus, transmission line, transformer, or interface, will be monitored if everything that it belongs to is set to monitor. Basically, its own monitor field, the group that it's in is enabled, and the area in the zone that it belongs to is enabled and meets the kV range. Remember, by default, all elements belong to the limit group named default, but you can change that by creating a new limit group and then assigning certain elements to that new limit group, as we did in the example. This slide shows in detail what is meant, the option of treating line limits as equivalent amps. The amp rating is calculated with this equation, which is based on the MVA rating and the nominal kV of the line. For buses to use the voltage rating sets defined by the A, B, C, and D limits, there's also a bus field called Use Specific Limits, which must be set to yes for each individual bus to make use of the A, B, C, or D limits. Back in Simulator, you can also right-click on a limit group and bring up its dialog to view a lot of the same information that you can on the case information display. Limit groups also have the option to use a piecewise linear limit cost, and this can be applied in the optimal power flow. This slide shows an example of a piecewise linear limit cost applied to the default limit group. Limit groups also have a field where you can specify the limiting end of transmission lines. By default, all of these are using the higher end. So if there are losses on a line and the flow at one end is higher than it is at the other end, Simulator will then use the higher of the flow to determine whether or not the element is overloaded. I can also toggle this to specify the lower end. That's also described on the slide here. Earlier we looked at the option to globally monitor or ignore radial lines and buses. This slide explains what a radial bus is. A radial bus is a bus that is connected to the rest of the system by just one line. A line is considered radial if it is the branch that connects the radial bus to the rest of the system. However, this note shows that PowerWorld Simulator is only able to determine in a situation like this where you have multiple buses that are strung in a radial configuration. Simulator is only able to determine that the last bus in this series is radial. So these buses right here would not be considered radial, and the lines that are connecting them would also not be considered radial. However, if you want to ignore lines and buses like this from the monitoring set, you could individually toggle the monitor field for those elements off, or create a new limit group for lines that are approximately radial, or for lines that you otherwise don't wish to monitor, and then add those lines and buses to that group. The tip on this slide recommends using the advanced filtering to help set up limit monitoring settings. In the case where we set up the new group that we called 500 kV, I used the advanced filtering to just look at the buses that were 500 kV and above. And in that way, I was easily able to transfer those buses into the newly created limit group. That concludes this session on limit monitoring and limit violations. If you need further assistance, please feel free to look us up on the web, give us a call, send email to our support line, or if you prefer to work with a particular PowerWorld engineer, please feel free to contact that person directly.